set aside place where the government was doing nuclear power testing. They were building nuclear reactor facilities, right? The ecology lab was there, as I look back on it, probably to give them some good publicity while they were busily making bad publicity happen, investigating nuclear power and nuclear fuel generation. Right? But Savannah River Ecology Lab had a group of ecologists, mostly from the University of Georgia, who worked down there, and they were looking at the after effects of spills of cesium that had been made by the nuclear power facility introduced to the river, Augusta, and other things that were related to that. They were also looking at the effect of cooling facilities for nuclear power plants, okay? And cooling facilities dump a lot of overheated water into ponds and rivers, right? And so they were also looking at the effect downstream of dumping all this hot water back into the streams and cooling. Things like, anybody watch The Simpsons? Remember all the little fish with many eyes? Mm-hmm. Yeah? Well, we didn't have fish with many eyes, but we sure had fish with sores on them. We had fish with high cesium content. Turns out that the heat actually disrupts reproduction. And so the alligators, the males, were coming into season a month before the females. So it was disrupting reproductive ecology. Turns out that turtles are a sex ratio in their offspring is affected by temperature. So if you have too high a temperature, you get all males. Too low a temperature, you get all female. In between temperatures, you get a male. All that work was going on there as a result of nuclear power reactors. And that's what got me interested really in research. So I was doing all these different kinds of research projects, exploring all these kinds of questions. Alligators, snakes, birds, humans, beef cattle, all kinds of stuff over time. Many, many kinds of questions to be asked out there, but I still obviously hadn't settled in on one. And then I decided to go back to school. I said, well, you can't really make a difference in this. Other people get to tell you what you get to do if you're only a technician. Right? So the boss says, this is what we're going to do, and tells me, go do this question, collect that data, bring those things in. Right? I like being in charge, right? I like being the one that's telling the other people what we should be thinking about and investigating. So I knew that to do that, we had to go back to school. So I went back to school. I started at the University of South Carolina, and I was still kind of torn, right? Do I want to do something like academic, like become a professor and change the way science teaching is done, or do I want to actually ask those research questions? And I had like big long lists there about the benefits of each and the costs of each and which one was going to be the best, right? And South Carolina, it turned out, was close enough so that I could take my son to visit his father, and also had a professor who worked on transforming undergraduate science education in biology. That was his life's work, and he was doing some really exciting, innovative things with new technologies. And they also had a professor there that was interested in behavioral biology and how animals evolved and how their circadian rhythms were set, and she'd done all kinds of exciting work in that area. So there were two people I really thought I'd like to go and work with. So I went to school there. And again, sometimes life just goes, and this is what's going to happen to you, kid, let's see what happens. Turned out that the guy that was doing science education had a heart attack that fall, and he wasn't any longer a professor there. The other lady was. So I ended up asking questions about behavior in biology. And because I'd done some work with alligators, And there was real interest in whether reptiles could actually have a circadian clock, whether they could use the sun and the moon and the stars to find direction, whether they had a clock in their head so they could tell time by using celestial cues. She was really interested in that, even though that wasn't her work. So I worked on alligators. And I've caught alligators before, 12 years. So I did my master's thesis on alligators, asking whether they could use the sun, the moon, and the stars to find direction, and whether they had a clock in their head. Now you may think, why would you want to do that? But there's all kinds of things that are controlled by circadian clocks. So in your bodies right now, there's biochemicals running around telling you what time of day it is and turning on certain kinds of hormones and proteins and other kinds of factors. They're all controlled by a circadian clock. If you didn't have a rhythm to turn them on at the right times, you've fallen asleep right now. And we could So your wake cycle is set by rhythms of chemicals being produced in your body. Your hunger cycle is produced by that. So all those things also have real relevance to humans as well. So it was a really interesting time. And it's actually fun to work on alligators and be the, for a while I think I was the only woman in the world that was working on alligators. Mostly a male kind of fun. Go to herpetology meetings, 500 scientists and 2 women. But the whole way through that, I kept getting more and more interested in the evolution of behavior. So how did these behaviors that we observe in crocodiles and snakes and frogs come about? And I took a really interesting course. So there was, 1976 it was, E.O. Wilson's book came out on sociobiology. So anybody heard of Ed Wilson? I should look him up. He was really amazing. He comes from Alabama, for the Alabamians over here, Alabamians. He's from Alabama, and he became one of the most famous evolutionary scientists in the world. He's been at Harvard for years. Came out with a new synthesis bringing together genetics, evolution, and social sciences to look at how behavior evolved in animals and humans. Now his work is mostly with ants. Not so much interesting to me. But his new synthesis had a lot to say about the evolution of human behavior. And we decided the year that came out to persuade my advisor, my professor, my mentor, to do a course reading group on that book. And every single person that was in that reading group is now a biologist that looks at evolution of behavior in some form or another. Every person. So it's a kind of a decisive but quasi-accidental event that precipitated all of us to think about that. And one of the things I got interested in there and then was the evolution of parental care. Notice this recurring theme about babies? I don't know. Something very, very strange about that. But so I got interested in the evolution of parental care. And so I went to do my PhD at the University of Florida because there was a woman there that was working on frogs where, so frogs usually you think about the female of the species lays the eggs and then hops away and the eggs just grow up. Right? But there actually are a number of frog species where males care for the babies and they carry them around in little pouches on their back, in their mouth, or in a pouch. Frogs. Is that weird or what? So it was the evolution of parental care, and so how is it that some animals care for their young and care for them for a long period of time, and other animals deposit their eggs and hop away? What is that? Right? So that was the kind of questions that I was interested in. And may sound like it's far removed from humans, but it's not. Because we also have evolution of human behavior questions that apply right along the same path. Why do we care for our young? What keeps us together? What kinds of behaviors make differential mating in humans happen? Those questions are all behind that. Right? So I went to Florida to study that. But it turned out that all of her work was in a South American country where there was a very serious war going on. And I had a 6-year-old. I couldn't do field work in South America and take a 6-year-old along if there was a war going on. And that semester, some more lemons. So my first year in my PhD program, the state government decided to cut the university's budget. And so on June the 1st, they told all of us graduate students we weren't going to get paid for the summer. Right? 6-year-old me, I rent to pay. Can't I get paid? Right? And I'm sitting there going, what the hell am I going to do? Right? This is horrible. My first year in PhD program, I have to leave because I'm going to have to get a job, right? And I'm walking across the parking lot that very afternoon. And the professor that I had for genetics that semester was walking across the other direction toward me. He was going, I got my grant, I got my grant, I got my grant. And he really was, just like that. He was so excited. And I went, really? Do you need a research associate? And he went, yeah. I said, I'm yours. How much you pay? And it turned out that he was working on the evolution of life history strategies, so it's related to what I was thinking about, but using a Drosophila model system. So that's the people. Right? So he was looking at a theory, so there was a theory out there that organisms that lived in very variable environments, including humans that live in very variable environments, were likely to, as the guy used to put it, live fast, love hard, die young. And organisms that lived in stable environments tended to have longer lifespans, fewer offspring, more parental investment in each offspring. Right? Big theoretical question with mathematical equations and all kinds of stuff behind it, right? But what we were going to do is test it in the lab with populations of fruit flies that we gathered from the very edge of their range, which at that time was in northern Michigan, where the temperature was really fluctuating, and very stable environment.